Welcome back, and we're on page 7 of your notes, and we're going to be just looking at some exam questions and how to answer them when we're talking about shape. So the first question is about methanol, and it's asked us to give approximate values for different bond angles and to explain or justify our answer. So we've got our molecule, so we have this as our molecule, we have our oxygen and our hydrogen there. So this is our methanol. And we're asked for two bond angles. We're asked for the HCH bond angle, so we want this bond angle here, and the COH bond angle, so we want this bond angle here. We should know from our notes that this is a tetrahedral arrangement, and we have a bond angle of 109.5, and this because the oxygen has the lone pairs. Lone pair repulsion is much greater. This has reduced the bond angle to 104.5. So when we're answering these questions, it's important to state, first of all, the fact that we have 4 bonding pairs of electrons, but that is not enough to gain us the justification mark. To justify why, therefore, those bonding pairs have a bond angle of 109.5, we say that this is so that they separate out to minimize repulsion, to maximize separation, and that leads to this bond angle. It leads to this tetrahedral shape. It's important that you both state the facts of the fact that it has 4 bonding pairs of electrons and the justification as to why, therefore, they adopt a bond angle of 109.5. The same for the COH bond angle, because here you've got 2 bonding pairs and the 2 lone pairs, but also the separate statement that the lone pairs repel more than the bonding pair, or the lone pair repulsion is greater than bonding pair repulsion. Therefore, we reduce the bond angle to 104.5. And it's the same for the peroxide molecule H2O2, where the bond angle again is 104.5. No matter which one we're looking at, this one or this one, they are still 104.5. And we have the same argument. Bonding pairs and lone pairs arranged tetrahedrally, but the lone pairs repel more than the bonding pairs. Again, the lone pair repulsion is greater than lone pair bonding pair, or bonding pair repulsion. So therefore, the bond angle is reduced from expected 109 from a tetrahedral to 104.5. So there are more shapes questions on page 8, and we're asked for the dot cross diagram of this molecule I2O5. And we have our normal double bonds between our oxygen and our iodine, and single bond to the linking oxygen. So if I draw this out in stick form, you have double bond there, and iodine has double bond there, but the iodine still has a lone pair of electrons on it there. So again, because of this lone pair, this bond angle is going to be very similar to the bond angle in ammonia, in other words, 107. So another example of an exam question was the BrO3- ion. In this case, one of these oxygens has already gained an electron from somewhere else, so it will form a single bond with the bromine. The others will form their normal double bonds. This one now has 2 lone pairs of electrons on it, as well as this extra electron, as do the others. And the bromine also has a lone pair of electrons. So I've got 3 sigma bonding pairs, 1 lone pair, so it's likely to be a T shape. So lone pair there, double bond to one oxygen, double bond to another oxygen, single bond to the last oxygen with a negative charge. So that's likely to be the shape, T shape. So the last section of these notes looks at 2 exam questions and 2 answers to that exam question, explaining why the bond angle in water is less than the bond angle in ammonia, despite the fact that they both have 4 areas of electron density. But if I put these in, it should be quite clear that oxygen has more lone pairs than nitrogen. So this answer here, because oxygen has 2 lone pairs, it gained the first mark, but it lost the second mark. It didn't give enough justification as to why having that extra lone pair would reduce the bond angle. The second answer makes a classic error that the student has talked about hydrogen atoms repelling rather than bonding pairs of electrons repelling. So this scores 0. You do need to be very careful that you are talking about bonding pairs of electrons that repel, not atoms, not bonds, and not electrons. The terminology in this is very, very important. So there are 2 marks for this question. The first mark is for saying that oxygen has more lone pairs of electrons than nitrogen. So oxygen has 2 lone pairs, but nitrogen only has 1. So that is the first mark. But that's not enough to get you the explanation mark. The explanation mark comes from the fact that these lone pair repulsion is greater than lone pair bonding pair repulsion, and therefore reduces the bond angle. And that is your second mark. And that completes your shapes notes.